I think it's very important for you to learn. Okay. Okay. To let the bulb have the normal brightness. Okay. First one, we're talking about the current and the power supply. Okay. So I think you understand already. To let the bulb have the normal brightness, the voltage supply across the bulb must be according to power rating. First one. Okay. So the next one you have to understand that about the brightness of the bulb depending on what actually. The brightness of the bulb depending on what when connected in the circuit. Okay. So I think that you have questions in the quiz that I gave you. Let me see. Okay. All this is okay. I think it's fine. When you remove the bulb on the three bulb sockets, so the two other bulb goes off. Okay, when the bulb then the bulb must have been connected in. Okay, so must be in series because once you remove it, right? So consider once is the not functioning, then actually the circuit is broken. When circuit is broken, so the circuit is not complete. It's not complete circuit, so that's why it cannot be light up the other two bulb. Right. Okay, so this must be the series circuit. Alright, so this advantage when we connected in parallel. When connected in parallel, one of the bulb is not functioning, is burst or what? The other bulb is still can be function normally. Can be function normally. Right? But in series cannot because series all on the same road. It's just like you on the when you're driving the car. There's a three car on the road because they are one connected to the other one series. When any one of car break down, the other car can move or not? Definitely the other two car cannot be moved. You have to cut the line. But there's no other line for you, then you cannot cut through. So the car breakdown will be blocked all the flow of currents, all the flow of the charge in the circuit. So that's why it not allow the other two bar to be light up. Right? So because it will make the circuit disconnected in open circuit. Right? Okay. So I think the rest is fine. It's just only some maybe you accidentally answer wrongly. Okay, anyway, come back to the point that I told you that you must learn, right? About the brightness of the bulb in the circuit. How we choose which bulb will be light up brighter than the other. Which color will be higher and then cause the bulb have higher brightness compared to the others identical bulb connected in the circuit. We're talking about identical bulb connected in the circuit. Okay. If the question really asks so, remember, if the question really asks so, then our considering is on the colors. Which bulb have the higher color, then the brightness of the bulb will be higher compared to the other lower color. Okay. So example like this. Okay, so now I have the bulb A, B, C, and D. A, B, C, and D. A, B, C, and D. Right. So my question is, which bulb is brighter in the circuit? All the four bar A, B, C, D, they are identical bar. They are identical bar. Which one have the greatest brightness? Which one have the greater brightness? Okay. Which one have the greater brightness? For this circuit, which one have the greater brightness? A, B, C, or D? Okay, any response? Which one have the greater brightness? Greater brightness. Is this D? Oh, agree with the D. Right, so now we look at the circuit here. Here is our current. The current, look at the currents here. When you come to this junction, you split into the two different I1 and I2. So what we know is the I is equal to I1 plus I2. So which one have the highest current because it have the greater brightness, right? So it should be the A. A will have the greater brightness. A will have the greater brightness because the current across the A will be the greatest in the circuit, right? Because the current received by the A is the effective I, right? Okay, so the greatest brightness will be the A, right? Okay or not? Right, so my next question is B and C. B and C will have the same brightness. Agree or not? B and C will have the same brightness. Do you agree with this statement? B and C will have the same brightness. Do you agree with this statement? I mean that the B brightness same as the brightness C, not the same as the A lah. I only say that the B and C have the same brightness. Do you agree this statement? B and the C have the same brightness. No, no, no. Why no? Why you disagree? The statement says so. B and C have the same brightness. Why you disagree? Anyone can try to answer why you disagree that B and C have same brightness. If you're typing slow, maybe you can on your mic. Any idea why you say so? The brightness B and C not the same. Why don't one want to talk? You know that the 2 hour talk to myself only is very, very lonely. You know? Sometimes it will cause me crazy. Okay, B and C is series arrangement. Why the series arrangement doesn't make them have the same brightness? Am I told you statement when there is the series arrangement that cannot have the same brightness? Yeah, from the beginning I told you they are identical bulb already. A, B, C, D, all are identical bar. Different current flow in series circuit or bar. Right. In the series circuit, there's only one current. Right. So you look at you look at my diagram, right? Look at my diagram. So okay, B have a current I1. How about the C? How much the current of C? Is I1 or not? The current received by the C. Is this the I1? The current received by the B and C is I1, right? Both receive the same current. I1, 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 I1. So again, will they have the same brightness? Right? So since they are receive the same current and then they are identical bar, so their brightness will be the same. The brightness will be the same. B and C will have the same brightness. Please take your own note. Right? B and C will have the same brightness because they receive the same current as showing in my diagram is I1. But this brightness for sure is lower than the bulb A because bulb A the current I is higher than I1. I1 is only a part of the I. I1 just only a part of the I because the I is the effective current. Effective current. Right, so that's why the brightness of A is a brighter compared to the B, C, and D. Right. So the B and C brightness are the same. B and C brightness are the same because B and C receive the same current I1. All right. All right. So there's a second information that you should know. So now come to the final questions. Since the B, C have the same brightness, right? So now for either B, for either C, compared to D, compared to the bulb D. So which one is brighter? I repeat again. B and C, same brightness. We already agree. We know because both receive the same current I1. So now either one here, B and C, all right? We try to compare to the D. Which one is will be brighter? Okay, why the D is brighter? Why the D is brighter? Because I2 is I minus I1. How you know that I minus I1 equal to I2, then I2 will be higher than I1? Okay, to make the decision whether the D is the brightest or not, we're going to comparing. We want to know I1, I2. Is I1 less than I2 or I1 more than I2? That is our question to answer. Okay, the only we know which one will be brighter. If we can prove I2 is higher than I1, then the brightness of the bulb D will be brighter. That is the one we have to prove. Yes, same voltage of D is shared between B and C. Right, so you got the point for the judgment, right? So you got the point already. So same voltage across the D, actually it will be shared by the B and C. So let's say the D we have the voltage across the D, but this voltage across the D is divided to the B and C because B and C connected in series. Right. Okay. So that's one of the point. but it's still not enough for you to answer to prove I2 is more than I1. Okay, use the Yin answer already because the resistance is smaller. D have the lower resistance, so that's why D will be brighter. Why? Okay, look at here. Okay, there's a correct answers already. When the question asks why the D brighter than B and C, right? Because D have the lower resistance. Yes, there is a correct answer. Due to the lower resistance of the D, actually it should say lower effective resistance for the D compared to B and C. Then for the colors, I2 will be higher than I1. Because here, you look at here, this one we have the RB, we have the RC, and then here's RD, right? Okay, so because they are identical bar, so it means that we can conclude that the RA actually equal to RB, equal to RC, equal to RD, because they are identical bar. Right? And then we know that the V across the D, equal to the V across B and C. Right? This V, the voltage. Here, this voltage. This voltage. Right? Okay. And the VD is equal to I2. VD equal to I2 multiply RD. And the B and C is equal to I1 multiply RB plus RC. Alright? So, and these two are the same. They're equal. Because they are connected in parallel. They are connected in parallel. So that's why the judge mentioned the V, B, and C, okay, actually is sharing the voltage same as the D, right? So because of that, then you can say so the voltage supposed to be higher, so that's why it has a greater brightness. But the problem is when you say so, actually you can't score the questions. As I mentioned before, when the connector in the circuit, to explain why the brightness higher or lower, our quantity to answer is current, not the voltage. Because the current is the one that deliver energy. Right? The current is the one that deliver the energy by the charge. There's a more charge, you have the more current. The more charge with the higher current have more energy because charge carry the energy. Right? So remember that. Okay, so that's why our proof, our answer to explain why the brightness is greater. So we focus on the current. We don't focus on the voltage. Voltage is lead you to knowing that whether the current is higher or lower. Okay. So based on this calculation, we know that I2 will be greater because with the same voltage, lower R will cause a higher I. With the repeat again, with the same voltage, lower R, it will cause a higher I. But higher R will have the lower currents. So from here, we prove that okay, RD compared to RB by RC, right? So RD will be smaller. When it's smaller, same voltage, we have a higher current. So that's why I2 is greater. That's why the bulb D will be brighter compared to the B and C. B and C is the same because B and C is I1. Right? So please take note for this one. Okay. So I repeat again, please take note for this. When the bulb connected in the circuit, to calculate the brightness, we are looking at the current. Right? We look at the current. It's a 1. Okay. But is this all the time like that? Okay. It's not like that. Especially, okay, please take for the second note. Especially when the question asks you to choose, asks you to design how the bulb able to produce greater brightness. I repeat again, when the question asks you to choose which design of the bulb able to produce brighter brightness or produce a higher brightness of light. Okay. Then you cannot say, oh, I designed the bulb can have the higher color because higher colors are not, it depends on the connected into the circuit power supply. We connected to the power supply with and deliver the higher color, so then the bulb will be brighter. So there's nothing to do with the color because we're talking about the design. It's not that the bulb connected into the circuit. Talking about the design of the bulb. How to ensure that the design of the bulb can able to produce a greater brightness. Alright. So this question also came out in past year one. They said, ask the student choose the design of the bulb. Okay. So please take note. How to choose which bulb has the greater brightness when connected to the circuit. So the answer is we look at the resistance of the bulb. Because design is talking about the physical design. What we can change is the resistance. And now the question is, we should choose the design have the greater resistance or lower resistance to produce the brighter light. I repeat again. Okay. We're going to design the bulb lower resistance or higher resistance to ensure that you can have the brighter light when connected into a circuit. You should go for higher resistance design or lower resistance design to get the brighter light. Right? Yes. Try guess, try to answer by smart guess. Come on. Right, so Patricia answer already, higher resistance design. Higher resistance design, okay? You also answer already, higher resistance. Why you go for higher resistance? So when you answer your modification is to look for higher resistance. Then now what is the reason? Why the higher resistance design can have the brighter light? Okay, I'll show you answer lower resistance. Higher resistance, more voltage. When you design the higher resistance, then you automatically have more voltage already. You have more or less voltage depending on the supply. Depends on the supply. Right. Okay. So okay, you want answer produce heat energy. Yes, you got the points already. Yes, it's all talking about the energy because we need to convert electrical energy into heat and light energy. So to have greater brightness, then the bulb must have the ability to convert more electrical energy into the heat and light energy. Then only it will be brighter. So that's why we are looking for high resistance design. Because higher resistance, it have an ability to convert more electrical energy into heat and light energy. So that's why the brightness of the light will be higher. All right. So we're talking about the design. We're talking about the design, and then we're talking about the connection in the circuit. So there are two different understanding. Okay, there are two different understanding. There are two different understanding. Right. So I hope that you now will be more clear for you about this part. All right, it will be clearer for you about this part.